Hello again. In this video we will do a comparison between the results of our code and the results from the well-known finite element analysis software, which is RFEM. This is the model inside RFEM. This is the modulus of elasticity represented properly or correctly, or the same as in our code. Also, the cross section 50 centimeter square, 50 centimeter square, and the element type is a truss, which can resist only axial forces. I will let's see the results. I will start by showing the displacement, the deformations. So the maximum deformation in y direction is 0.7, and in our code is also 0.69. So this is the deformed shape inside our code, and this is the deformed shape inside RFEM. What we can also, so this is the displacement is okay. We can see the reactions. The reaction 66. This is 66.67 and 50, and also 66.67 and 50. And the axial forces, member forces 83, and this is the same, also 83 and 83, and this is completely compatible with the hand calculation and hand calculations, and the results of our code and the results from RFEM software. Also, one more example which is more complex. This is another example. In this example I have more elements, seven elements, and a nodal force at node number 5, which is 200 kilonewton, and all the dimensions are shown on the figure. Again, the same modulus I use the same modulus of elasticity and the same cross-sectional area. I will run the model. So this is the model printed, and this is the deformed shape. And let's see the deformed shape from RFEM. This is the model inside RFEM, and this is the deformed shape. How much is the maximum deformation is 1.72, and from our code one 1.72 acting downwards. We could check the other nodes also. Let's see this and this one. So 0.474, and this is 0.74 in y direction, and in x direction 0.3, and this is also 0.3 in x direction. one time positive, one time negative. Uh, so let's check the reactions. The reactions are 100, 100, 40, 40, 100, 100 and 40 and 40 kilonewton. Let's check also the axial forces. The axial forces N compression 107, and this is the first element, compression 107, 100 compression the second element, the third element also under compression 107. This element, it has no forces inside, 0, and the other element also 116, 116. This is 116 and 116 for element number 6 and 7. 4 and 5, they have no axial forces inside. And this is also completely compatible with our code. Then right now we are done with our code and with the comparison. So I hope that was helpful for you, and see you in another tutorials. See you later.